A content they commonly call Sky Math. I'm here again on the same point again to give a tutorial on physics, gravity as a topic. And gravity is also one of the key topics in high school. So what we mean by gravity? Gravity simply means a force that acts on all bodies. So any force that acts on all bodies or objects or particles, that force we refer to get gravity. You see. So in this point, the next phase we have to capture how gravity try to affect other bodies. In this case, let's try to consider the relationship between gravity to weight. So the relationship that shows gravity to weight, gravity is related to weight, W equals to mass multiplied by the gravity G. So in this simple form, we have weight to be mass times gravity. Since we have weight equals to mass times gravity, so there are certain things we have to capture. Because these three quantities, two of them vary due to the particular place, while mass remains constant. So in this case, we have to take note of mass is always constant. Like if you consider on Earth, the mass of this marker on Earth is always constant. If this mass is 2 kilograms, if I try to take this marker on the moon, on Earth, Jupiter, Pluto, wherever, this marker only has the mass of 2 kilograms. So mass is constant at every place. But these two quantities vary. So see, the gravity varies from place to place. What are some of the reasons that makes gravity to vary from one place to another? One of those reasons is because like the Earth, the shape of the Earth. Because since the Earth is not a perfect sphere, that means the gravity varies from place to place. Because if you capture it, we have a circle to be in this form. This is the center of the circle. From here to here is radius. From here to here, any part of the circumference. And that line is coming from the center is radius, it's the same. But the Earth is in this form, like this. So if you capture here, the magnitude of this center, which is simply the equator, the magnitude of the distance from here to there varies from here to there. So the distances varies from each place. So this again another reason why the gravity varies. Because the magnitude of the Earth, the magnitude of the distance, the magnitude of the force, and the Earth is not a perfect sphere, and the shape of the Earth. These are some of the reasons why gravity varies from place to place. Now, so we have weight equals to mg, since we all know that mass is constant. So the values which vary will be the gravity. When the gravity varies, definitely the weight is vary. Because the weight is directly proportional to the gravity. The higher the gravity, the higher the weight will be. You see. In a scenario like if my weight on Earth here is 2 newtons, you see, if I go to the moon, my weight will be less. You see, because like we have the gravity on Earth to be far away off greater than to that of the gravity we have on the moon. So let's consider these different gravities. Let's start with the gravity on Earth. The gravity on Earth, we used to know it to be 9.81 meters per second square or 10 meters per second square. The gravity on the moon, we have it to be 1.621, because simply approximately 1.621 meters per second square. We have the gravity on Mars to be 3.711, approximately 3.711 meters per second square. And we have the gravity on Jupiter to be approximately 24.7945 meters per second square. So these are the different gravities in different places. So we consider this for, so our point here is, since we have weight equals to mass times the gravity, let's try to find the relationship between the gravity on Earth to that of the moon. You see, so what's going to the relationship of the Earth to that of the moon? But the relationship of Earth to that of the moon, the relationship of the moon is always going to be 1/6 the gravity on Earth. The same way again, the weight on the moon, we should know it to be 1/6 times the weight on Earth. So this is the derivation I just want to derive here. But how are we going to go about the derivation? Let's start. Since we have the weight to be mass times the gravity, let's say we are looking for the weight on Earth. A. Weight on Earth is going to be the mass times the gravity on Earth. Let's say this is the first relation. There is no need for us to say the mass on Earth. If I told you mass is fixed, if the mass of a body is 5 grams, when that object is taken to Jupiter, Pluto, Uranus, Venus, wherever that object is taken to, the mass will always be the same. So no need to say mass on Earth. So weight on Earth will be mass times the gravity on Earth. Similarly, the weight on the moon is going to be mass times the gravity on the moon. This gives us equation 2. So if we want to have derivation, let's say we divide equation 1 by 2. If we divide 1 by 2, let's say divide equation 1 by equation 2, we say weight on Earth equals to mass times the gravity on Earth. We divide both sides by equation 2, which is weight on the moon. Weight on the moon. So we can see that mass cancels mass. So what it means now, we have weight on Earth divided by weight on the moon equals to the gravity on the moon equals to the gravity on the gravity on Earth divided by the gravity on the moon. So if we move forward to express this again, we have the respective values. If we rewrite weight on Earth all over the weight on the moon, but conveniently, we have the gravity on Earth to be 9.81 or 10. We can either use either. Let's say we use 9.81. 9.81 divided by, and we also have the gravity on the moon to be 1.62. 1.621. So if we divide weight on Earth divided by weight on the moon, if we divide 9.81 divided by 1.62, we have 9.81 divided by 1.621. We have a value of 6.05181986 newton. So if we have that value to be short, so in this case, if we round it up to a whole number, approximately this is going to give us 6. So when we cross multiply, the weight on Earth is going to be 6 times the weight on the moon. So this tells us that if somebody is on the moon with the weight of 5 newtons, right, if that person comes to the Earth, that person will definitely have the weight of 6 times 5, which will give us 30 newtons. So in simple sense, a person on Earth will weigh more than when that person moves to the moon, right? Because the weight on the moon is less than compared to the weight on Earth. So this is just the derivation. So if we make the weight on the moon the subject, so the weight on the moon is going to be 1/6 that on the weight on Earth. This is just the first relation. So if we want to have it in the second relation, also the weight on the moon, we have it to be, since the weight on the moon, to have the second one is 1/6 times the weight on Earth. But we have the weight on the moon to be mass times the gravity on the moon. We maintain our 1/6. What is the weight on Earth? It's the mass times the gravity on Earth. So carefully, mass will cancel mass. So the gravity on the moon, we end up having it to be 1/6 times the gravity on Earth. So these are the derivations I just want you guys to take note of. So in terms of weight, the weight on Earth is always 6 times the weight on the moon. And conveniently, the gravity on the moon is 1/6 times the gravity on Earth. So you have to capture that. So let's try to see how these questions are done. We have basic problems here which we are going to solve together. Let's consider the first one. This first one says a man weighs 100 newtons on the surface of the moon, right? If the acceleration due to gravity on the moon is 1/6 the value on the Earth, calculate the mass of the man on the Earth. You see? So we have to make our data. What is given to us? We have a man weighs 100 newtons on the surface of the moon. So this weight given, the weight on the moon is given as 100 newtons. If the second statement says, if the acceleration due to gravity on the moon, that the acceleration due to gravity on the moon is 1/6 that's on the value of the Earth. So this is what we are given. You see? So we are required to calculate the mass of the man on the Earth. You know, the mass of the man on the Earth will be the same as the mass of the man on the moon, will be the same as the mass of the man on Pluto. So let's calculate the gravity of this man. The gravity of this man on the moon is going to be 1/6, but we are given the gravity on the Earth to be 10. We substitute it. So the gravity of this man is going to be 1/6 times 10, we have a value of 1 over 6 divided by, so we have the value is 1.66, approximately 7 meters per second square. So this is the gravity of the man on the moon. But we are required to find the mass. But we have weights on the moon to be mass times the gravity on the moon. So since we are given the weight on the moon to be 100 equals to mass times the gravity on the moon, which we have calculated already. So since we are required to find m, divide both sides by 1.667. Both sides by 1.667. So this carefully cancelled. So the mass now will be 100 divided by 1.667. So if we divide 100 divided by 1.667, we have something like 59.988 kilograms. So this 59.988 kilograms is the mass of the man on Earth, which can as well be the mass of the man on the moon or Pluto or any planet. You see, this is the first question. Let's try to have again another similar question, and we'll try to have a gist on it. But there are certain things we have to capture there. On the moon, we have to capture there is gravity, which we have as 1.621, less gravity. Because when you consider these two gravities, the gravity on Earth is far away or greater than this. You see? So in this case, on the moon again, we have to take note of that. There is no air on the moon. That's the reason simply the astronauts, they cannot communicate by themselves unless they try to use means of mobile phones. Because like there is no air on the moon. Since there is no air on the moon, so it simply means the gravity in respect to that is very less. So if we capture the second question again, the second question says the mass and weight of a body on Earth are 8 kg and 80 newtons. So we have the mass of this man on the moon to be 8 kg. On Earth, the mass of the Earth is 80 kg and the weight on Earth is given as 80 newtons. So the mass of Earth, the mass of the object on Earth is 8 kg as given here. And the weight of the Earth on the object is given as 80 newtons, as we have here. Now the question says, determine the mass and weight of the body, respectively on a planet which we don't know, where the pull of gravity is 1/8 that on the Earth. Now let's say the gravity on this planet, we don't know the planet, is according to the question, is 1/8 times the gravity that on Earth, which is on Earth. You see? So the gravity, let's look for the gravity on the planet. So it's going to be 1/8 times, what's the gravity on Earth, which is given as 10. So therefore the gravity on this planet, 1/8 times 10 will give us 1.25 meters per second square. So we have the gravity on this planet, but the question says, determine the mass and weight of the body respectively on a planet. So since we have the gravity of the planet to be this, so we are required to determine the weight of this planet. So the weight of the planet is going to be mass times the gravity of the planet. But the mass now is fixed. Like I said, the mass on Earth, the mass on Pluto, Jupiter, anywhere is going to be the same. So calculating the weight of the planet is going to be the mass of this, which is 8, which is fixed, times the gravity on the planet, which we have as 1.25. So multiplying 8 times 1.25, we have 10 newtons. You see the difference? You see the difference? This man on Earth weighs 80 newtons. When this man moves from Earth and moves to the planet, on this planet, the weight totally will decreases to 10 newtons. So the other part of the question, we are as well required to determine the mass and weight. So to find the mass again, the mass of this man on this planet, I hope you guys all know it to be 8 kg, because the mass is constant. This is just the values we are required to calculate. We are required to calculate the mass of the planet, which is going to be the same as this, and the weight of this planet, which is going to be that same. So thank you all. So subscribe to my YouTube page. So I'll be bringing you more updates on physics. Thank you.